Alright, so we're talking about slopes of perpendicular lines, and your learning target is I can identify, graph, and write equations of perpendicular lines. So to get started with this, the first thing I want us to do is I want you to answer this question. We've got this shape right here, and I'm asking you, is the shape a right triangle? I want you to write yes or no next to guess. Is it or is it not? For it to be a right triangle, just to let you know, a right triangle is one that has one right angle, or a 90-degree angle. So essentially what I'm asking you is this a right angle? So let's define what a perpendicular line is, okay? Perpendicular lines are two lines that intersect, that means they cross at 90-degree angles. So 90 for this blank here. They cross at 90-degree angles. So essentially, if I were to draw this out, it would be where I have two lines. When they intersect at each other, a 90-degree angle is formed on all of those sides, okay? So here's the question. How do we really know if two lines are perpendicular? I mean, just by looking at it, you can guess, but do you really know if two lines are perpendicular? That's what we're going to talk about today, okay? So I know on your paper it's in black and white, but I've got blue, red, and green lines here. I want you to tell me which two lines you think are perpendicular. Which two lines do you think, when they intersect, form 90-degree angles, okay? Is it blue and green? Is it blue and red? Is it blue and red and blue and green? I say both if you want to. Which two lines, or both lines, do you think cross to be 90-degree angles, okay? Then answer this question. What would we need to know in order to prove that those two lines are perpendicular? What do you think? Take a guess. What do you think we would need to know? Do we need to know something about angles, something about sides, something about equations? What in the world do we need to know? Okay? So take a second, do that, pause the video if you need to, but take a guess. So here's the deal. I'm going to go through these equations here. Just give you the equation, see if that'll help us out at all. The blue line equation, the equation for the blue line is y equals 3/2 x plus 5. The red line equation is y equals a negative 2/3 x minus 3. And the green line equation is y equals negative 11/15 x plus 2. Okay, I just want to ask, take a second guess now, a second little opportunity. It's a little deal or no deal. Do you want to change your first guess? Based on the equations of the lines that I gave you now, which two lines do you think are perpendicular? Take a guess. So you should have already taken a guess by now. And if you haven't, go ahead and pause the video and do so. But I want to go through this definition here, okay? So the slopes of perpendicular lines are opposite, okay, this first blank is opposite reciprocals, okay? Opposite reciprocals. And I'm going to go ahead and write in reciprocals because I oftentimes misspell that, okay? And they should, the two slopes of two perpendicular lines, they should multiply to equal a -1. -1 for that last blank there, okay? So essentially what this is saying is that the slopes of perpendicular lines are opposite reciprocals. Opposite meaning if it was negative, now it's positive. If it was positive, now it's negative. And reciprocal meaning if you had a fraction like 1/2, the reciprocal of 1/2 is just 2/1. Okay, so 1/2, the reciprocal of that is 2/1. Okay, that changes the reciprocal. Positive, negatives are the opposite. All right, so let's do an example here. It says, what is the slope of a line that is perpendicular to y equals negative 3x minus 5? Now here's the important part. We need to know what the slope is of this line. We know m always identifies the slope. Okay, so -3, and we could technically put that as a -3/1, is the slope of the line that is given. Okay, we want to know what slope is perpendicular to that. So in order to change this up, then in order to find the slope of a line that's perpendicular to this line, we have to tell what the opposite reciprocal is. This one's negative, that means we're going to have a positive, okay? And reciprocal, we had 3 over 1. Now we're going to be talking about 1 over 3. We just flip the fraction there. Okay, so the slope of a line that is perpendicular to y equals negative 3x minus 5 is 1/3. M equals 1/3. And we can check this because we also know that the slopes of the two lines should multiply to equal -1. And we'll take the slope that we just found, 1/3, and let's multiply that by the slope of this one, which is a -3 over 1. We see 1 times -3 is -3. 3 times 1 is 3, which reduces down to -1, which means that this does, in fact, check out. Example 2 is much like the first example here. It's asking us to find what is the slope of a line that is perpendicular to 5y equals 3x plus 20. Okay, so the very first thing we have to do is find out what that slope is, and the easiest way to do that is to get an equation into slope-intercept form, which means we have to solve for y first. Okay, so we have 5y equals 3x plus 20. And if we're trying to solve for y, then all we have to do is divide by 5, because then that'll get y by itself. Because we see 5 divided by 5, they cancel each other out, and we're left with just y is equal to 3x divided by 5 is just 3/5 x, and 20 divided by 5 is actually 4. And so the equation that is equivalent to 5y equals 3x plus 20 written in slope-intercept form is y equals 3/5 x plus 4. All right. Now we want to know what is the slope of a line that is perpendicular to that. That means we have to have opposite reciprocal. So our slope of this line, remember, is m, so it's 3/5. That's the slope of that line. The opposite reciprocal, this one is positive. That means we're going to have a negative. Reciprocal, meaning 5 is going to become the numerator. 3 in the numerator is going to now be the denominator. So m, our slope, is equal to a -5 over 3. And again, we can check that out by multiplying these two together. 3/5 times a -5/3. 3 times -5 is -15. 5 times 3 is 15, and we see that does equal, I'm writing off the page here, that does equal a -1. So that checks out. So let's go back up to that first example that we had at the very beginning. This is the same exact shape that I showed you, and I said, is this a right triangle or not? How do we know? And we know that now that we have to figure out if it's a right triangle by finding the slopes. And if the slopes are perpendicular, then we will know if it's a right triangle. Now, I didn't give you any grids on that first one, but I've given you some grids here. And we know that the two lines that have the best likely chance of being a right angle are these two lines here. So let's find the slopes of this line. I'm going to label this triangle first as A, B, and C. And the slope of AB, line AB, we see goes down 1, 2, 3, 4, and it runs 1, 2. So the slope is a -4 over 2, which reduces down to -2 over 1, or just -2. Okay, and the slope for BC, slope of BC is equal to a rise of 1, a run of 2, 1 over 2. Okay, and so we can see right now, because I said this is a -2 over 1, the opposite of -2 over 1 would be a positive. The reciprocal would be 1 over 2, which is what slope of BC is. That means that these two lines are perpendicular, meaning that they are that this angle right here is a right angle. So we can say then that triangle ABC, and I'm using this little symbol for triangle, is a right triangle. It is a right triangle because the slopes of AB, line AB, and BC, line BC, are opposite reciprocals. And that makes us very, very happy.